in a second and show you UDP glucose and how that's formed. So UDP glucose is actually a glucose molecule linked to a sugar nucleotide. Okay. What sugar is this? What sugar is that? 5 carbons. Ribose. You need to know that for the microtest tomorrow. Linked to a base, 2 phosphates, and then our glucose molecule. So this is referred to as UDP glucose. So we are linking a sugar phosphate to a nucleotide triphosphate. So this is an NTP forming a inorganic phosphate, and then the sugar molecule, 2 phosphates, our ribose sugar, and then a base. Okay, so this is actually the substrate for glycogen synthase. Okay, so here's our UDP glucose. Again, uracil, ribose, phosphate, then the glucose, which are linked together with this is your elongated glycogen chain, okay? And then removing the UDP portion of the sugar, okay? So glycogen synthetase is not necessarily linking a glucose to a glucose, but taking UDP glucose and adding it to the elongating glycogen chain, okay? So really the first step is creating the UDP glucose, and this is from a glucose phosphate molecule, then adding them to the growing glycogen chain. So that creates this long chain of glycogen, and again, these are the 1,4 linkages between the glucose molecules, right? Then glycogen also has the branch points. So the 1,6 linkages between the 2 chains. The end that has the free hydroxyl we consider the non-reducing end. Okay? So this would be the end of the glycogen molecule. So there is an additional enzyme, glycogen branching enzyme. This one's like cleverly named. That creates the branch points. And it's responsible for creating the 1,6 linkage on glycogen. So to start, I'm going to go back to that. This is just a generalized structure of a glycogen molecule. So these are the branches coming out of there, are the chains, and then right where these 2 linked, that should be a branch point. Okay. Glycogenin is the enzyme responsible for starting a new chain of glycogen. Okay. Oops. Apparently you don't like that slide. So it starts the new chain and is able to then extend on from the new glycogen chain. Okay. So this is UDP glucose creating a covalent bond to the enzyme. So this is the enzyme up there, and this is the tyrosine 194 that starts the glycogen chain. So it's like, in essence, DNA polymerase that can't start without a free 3' end. Glycogen synthase can't start without a free hydroxyl group on the glucose. Okay? So to start the chain, glycogenin covalently links the UDP glucose to itself, which is then able to add additional UDP glucose molecules starting the chain. So this represents the start the enzyme of the new chain. Okay? So let's focus again on glycogen. So we've created glycogen. We're storing it in the cell. Now we need to use it for later. We are breaking it down. So we've got these long polymers of glucose. The enzyme responsible for removing them is glycogen phosphate. Phosphorylase. Jeez, I'll be right. And it took my time right now. So this removes a glucose phosphate, 1-phosphate, from the end of the glycogen chain. So here would have been the original non-reducing end. So like I mentioned, the end of the chain. Glycogen phosphorylase removes the last glucose with the addition of a phosphate. So now the molecule that's created is glucose 1-phosphate. Is that a substrate for glycolysis? As is. Will this enter glycolysis? Yes, no? Is this phosphate in the right place? What's the first step of glycolysis? Glucose to glucose 6-phosphate. Do you think that enzyme that catalyzes the next step will work with a glucose 1-phosphate?
I won't be able to find that phosphate.
No. This is in the wrong spot. So the first part of transferring glycogen to a usable form of glucose is isomerizing the glucose 1-phosphate to the glucose 6-phosphate. So this form of glucose will not feed directly into glycolysis. So when we're entering glycolysis from glycogen, so this would be our first step in glycolysis, right? Glucose to glucose 6-phosphate. What's the enzyme that catalyzes that? Hexokinase, right? Okay. But when we're entering from glycogen, in reality, the first step into utilization for glycose is catalyzed by phosphoglucomutase. So the enzyme responsible for changing it from glucose 6-phosphate, glucose 1-phosphate to glucose 6-phosphate. Yes?
So with diabetic emergencies, why do the medics stick them with or give them glycogen instead of just like glucose? Are they running out of hexokinase, or is that kind of like a more medical question? Because they got the popsicle sticks with glucose.
Yeah. I'm trying to think of the answer to your question.
And I didn't know if glucagon was like the brand name for glycogen.
No, glucagon is the enzyme. So there's different, the hormone, right? So glucagon is a hormone.
Oh, okay, so.
Are you talking about that, or are you talking about actual glycogen? Because I don't think they give them glycogen. I think they give
No,
them...
they give them, I'm sorry, I meant glucagon.
Yeah, so that's so it's like the opposite of insulin, right?
Okay.
Yeah. So glucose that's coming in from glycogen is actually coming in through the pathway through glucose 1-phosphate being isomerized into glucose 6-phosphate. So really, when we're talking about that initial step of glycolysis, we're really talking about coming in from multiple pathways into the generation of ATP. Okay. So glycogen phosphorylase removes the glucose 1-phosphate from the chains, right? But at the branch points, it's a little bit different because it's a different link between the glucose. So here's the 1,4, this is the 1,6. So glycogen phosphorylase only works on that non-reducing end of the glycogen molecule. So it will work there until it hits the branch point. Then at that point, the debranching enzymes transfers a block of 3 residues from the branch points onto the end, where then the glycogen phosphorylase can continue to remove from that non-reducing end. Okay. Left with only one glucose molecule attached here, that can be removed by the debranching enzyme and used in metabolism. Okay. So glycogen phosphorylase catalyzes this reaction up until it reaches 4 molecules before the branch point. The debranching enzyme is able to transfer those last 3 onto the end, creating a new non-reducing end for glycogen phosphorylase. The debranching enzyme removes the last glucose, which then can be utilized, and then further removal of the glucose molecules from the end of glycogen can happen. Okay. So this is the process of breaking it down and then allowing it to enter into glycolysis. Okay. So again, after the glucose 1-phosphate is created, it's isomerized to glucose 6-phosphate, which then can enter into the cell. Glucose 6-phosphate is dephosphorylated out of the liver to be utilized in other parts of the cell. So in this case, glucose is removed from the phosphate. Glucose is able to travel through the bloodstream to other parts of the cell that is needed. Because obviously, glucose 1-phosphate cannot be ultimately utilized by every parts of the cell, every parts of the body. Yes?
What did you say about glucose?
Glucose is dephosphorylated. So glucose 6-phosphate dephosphorylated into glucose. Glucose is then able to travel to other locations of the body. Okay, so control of glycogen breakdown. Oh, we're totally out of time. Okay, so glucagon and epinephrine signal pathways. Yeah, we'll work on this not Friday. I was going to start on this, but we're going to run out of time. Any questions?